Okay, great. In the interest of time, let's get started. Thank you all so much for joining us today. Today's Toolbox Tuesday session is working with census data in R, analyzing and visualizing trends. And I am joined by my colleague, Echo Jung, who will be walking us through the demonstration today. Next slide, please. Echo, we can go to the next slide. Apologies, I think we're having a bit of connectivity issues. So give us just 1 minute. All right, so on this slide, you'll see a number of housekeeping items to keep in mind during the presentation. The anticipated meeting length for this meeting is 1.5 hours to end at 2:30, and this meeting is being recorded. Please make sure that you are muted unless you're actively asking a question. And at the end, there will be a Q&A session. So please, as we're going, please feel free to post your questions in the chat. And depending on the nature of the question, we'll either answer it as we go or wait until the Q&A session at the end. I also wanted to let you know that closed captioning can be turned on by clicking the Show Captions option on the Zoom ribbon at the bottom of the screen. And a recording of this webinar and the PowerPoint slides, as well as the training materials, will be available on the SCAG website. And we will send a link to everyone who has registered after this event once those have been posted. And then just a heads up, please stick around until the end because we have a short survey that we ask you to please take so you can help us make sure future Toolbox Tuesday sessions are high quality. And so now I'd like to offer a land acknowledgement. We are currently on occupied and unceded land of Indigenous people who are and have been the traditional caretakers of land in the region. I am calling from Chumash land. If you haven't already, I encourage you to visit the resources I will share in the chat to learn more about the land and Indigenous communities where you live. And with that, I will pass it over to my colleague, Echo Jung, Senior Regional Planner at SCAG within the Demographics and Growth Vision Business Unit.
Thank you, Amanda. Hi again. Hi everyone. This is Echo, Senior Regional Planner with the Demographics and Growth Vision Business Unit. Apology, I'm having a little bit of technical issue. Hopefully it will run smoothly from here on. But this is the second time I teach R through Toolbox Tuesday and focusing on census data. The goal, the key objective for today's session is to extract, process, and map ACS data in R. This is an integrated workflow that I've personally found very helpful and worth learning because typically we go to the census website to download the data and then we'll probably process it through Excel or another tool, and we'll typically map the data in using tools like GIS. But with this integrated workflow, we can do all these things, everything in R through a little bit of programming skill. So hopefully this will be helpful to you as well. The practice example we will go through today is to analyze and visualize changes over time. To give you an example of what can be produced in R, so here you are looking at the number of remote workers in Orange County at the census tract level through 2 time periods. So these 2 time periods are roughly a decade, not roughly, they are a decade apart. And you can see that the number of remote workers increased most drastically just in certain neighborhoods within Orange County. So definitely not everywhere. Later on in R, this is actually interactive. You can zoom in to see where the number of remote workers have increased most drastically. This is a list of very helpful resources. As Amanda mentioned, all the training materials will be posted as SCAG's website. And if you're interested to learn more, learn more about ACS data or just using R in general, these are very helpful resources to begin with. So before we start, we will go through a couple ACS 101. ACS, I'm sure it's not a term that's new to most of you. It's the American Community Survey. It's a very helpful tool for people that are involved in analysis in pretty much all fields in social science. It provides detailed information about people in housing. Every year, the Census Bureau survey 3.5 million households to produce estimates related to social, economic, demographic, and housing characteristics for throughout the US and for Puerto Rico. So it covers a lot of subjects, as you can see on this table. That's why even just for finding the right variables from ACS itself could be a challenge. So we are also going to spend some time to talk about how we can find the ACS variables we need. There are two key ACS products. You might have heard of the 1-year ACS, and then sometimes people say we use 5-year ACS for this study. Why is that? The key difference in these two data products is in the geography availability. So the 1-year estimates are available for geographies of 65,000 or more in population. In the case of California, this is many of the counties. The ACS 1-year estimates are released annually, officially started in 2005. The latest one we have right now is for 2023, and the 2024 1-year ACS is actually coming in just a few weeks in September. So you can imagine that for the available geographies, you can extract annual data and look at the trends for almost the past 2 decades. So the 1-year ACS really provides the most current data. On the other hand, the 5-year ACS are available for geographies that are smaller, down to the census tract and block groups level. The 5-year ACS are also, they are called 5-year ACS, but they are also released annually. So when the data is released, it reflects the condition for the past 60 months. So for example, right now, the latest 5-year ACS we have is the 2023 5-year, and that reflects the condition, that reflects the data collected from January 2019 to December 2023. So at the end of this year, we will have the 2024 5-year data, and that will reflect the data collected from January 2020 to December 2024. So the key takeaway here is that you use the 1-year ACS when the most current data is needed and when it's available for most of the large geographies. And you use the 5-year ACS when you want to examine these geographies that are not available in the 1-year estimate. And in that case, you won't be able to look at an annual trend, but you can definitely still compare 2 time periods that are further apart, like the example I just showed you. So I also mentioned the term geography a lot. Census geography, it's also an important concept if you want to use census data. we as planners often need data for counties, places, and tracts. These more kind of localized data. So you can see at the bottom of this chart, within the rectangle that I drew, you see that counties, census tracts, and block groups, they are connected with a solid line. That means that these are nested geographic units. In other words, all census tracts are nested within a county, and then all block groups are nested within a given census tract and hence fully contained within a county. And from the perspective of data extraction, that means it's fairly straightforward to get to identify all the census tracts within a chosen county or get all the block groups within the chosen county. That's not really the case when we want to get all the census tracts for a particular city. So in census geography term, cities and unincorporated areas are called places. You can see where my arrow points to on this graphic. So you don't really see a solid line connecting places to counties or census tracts or block groups. So yes, not even counties. That means these are not nested geographies. So a census tract could span multiple places, or multiple cities or multiple incorporated areas. And in some cases, a city can span multiple counties. One example would be New York City that span 5 different counties. So that just means it's a little tricky if you have a city in mind and you want to look at all the neighborhoods in mind. So in the Toolbox Tuesday in July last year, I actually focused on analyzing neighborhood conditions within particular cities. So it's not really the focus for today's session, but you're welcome to check out that previous session in this topic. But I thought I would mention it here. So before we move to R, did I jump too fast? Yes, there you go. I also want to talk about a couple ways to find my ACS variables. As you can see earlier, the ACS covers many topics, and within each topics there are lots of variables. So if you're not a frequent user of the ACS, even getting the right variable could be a little challenging. The first place you can start is the census data profiles. Amanda, maybe you can help me drop some of these links in the chat. And this is also included in the pre-session materials if you already have a chance to review them. So the census produced 4 separate data profiles covering four different topics. Those are demographic characteristics, social characteristics, economic characteristics, and housing characteristics. So each data profile essentially provides a short list of commonly used variables that are under that topic. So for example, the housing characteristics data profile will provide variables including tenure, total housing units, unit types, years, structure built, and etc. So if you are looking for a quick stats, a commonly used stat for a particular geography that can be a quick place to start, and the use of the data profile is fairly straightforward. You go to the page and it's pretty much like a click and choose step-by-step process. So apology, I'm not going to do the demo for each of these options because we are going to focus on R in a bit. The second resource I want to highlight is our curated list of commonly used variables. These are resources that we put together when we need to give a session, like today's Toolbox Tuesday session. I share one of the spreadsheets in one of these resources in the pre-session materials as well. put together by my colleague, Dr. Kevin Kane. Essentially, this is a list of roughly 120 commonly used variables, ranging from populations to other demographic variables. I think that list is primarily focused on demographics and housing, because Kevin is our demographer of the agency. But 100 something variables is also a good place to start. After all, there are over 28,000 variables in the 2023 5-year ACS, and usually it slightly increase over time. I've also provided a link here where you can find this complete list of variables in the ACS data set. But actually, we can also look at that in R, which I'll show you later. Another way to find your variables is through going through some publication that indicate their source variables. Indicating your source variables is a good practice, and that's what we've been doing. We've been producing highlights and insights from the 1-year ACS data pretty much right after the data release for the past couple years. Here are the examples of the 2022 and 2023 report. We will do another one when the 2024 1-year data is released in September, and we will release the report on October 1st, which is the date for our 36th demographic workshop. Highly encourage you to check that out, and Amanda will provide more information at the end of this session. So the example I'm showing here is actually from the report on the ACS 2022 1-year data. You can see at the end of the chart, I put that the data is from the table B08006. If you have a pen and paper with you, you can write it down, because this is also the variable we are going to work with today. It's on work from home, well, commute mode in general. I'll show you later. The good thing with this is that it tells you exactly what the variable, which table is from. So from here, so it's just increased transparency, and then if you want to verify the data, that makes it much more easier. Anyway, we will try to do this in R, specifically starting with variable or table B08006. And before I switch to R, I'm gonna pause here and see if we have any questions. Okay, great. I'm not seeing any question so far. So Jennifer, I am going to try to share my screen. I don't know if you all noticed that I've been having a little bit issue with screen sharing today, so fingers crossed here. I'm going to share my application window this time, because sharing the whole screen has not been working. Okay. No. If it looks like I freeze here, it's because it gets a little glitchy when I share my screen, and I want to give it a couple minutes to react. So, Amanda, can you give me a confirmation that you are seeing my screen?
Hi, Echo. Yes, I can confirm we see your RStudio.
Okay, and And everything, the fonts is okay?
Yes, everything looks good.
Whew, awesome. Okay, I was hoping to share my whole screen, so it's a little easier, but I guess we'll do the workaround, so I'm only sharing my application window. Um, actually, Amanda, can you also help me share the script to the chat?
Absolutely.
Okay, so while we're doing that, yeah, let's just go through this interface together. So Amanda will be sending to the chat this script, so you'll be open it in RStudio, and we are going to run the script line by line together. And hold on one second. Let me, let me give this to Amanda. Let's pause for like a minute here as we're doing some file transfer. Amanda, were you able to download the script?
Yes, the script is posted in the chat.
Awesome, thank you. I'm a little afraid to do more with my Zoom because it might act funny. So if this is your first time opening opening R, and again, apology, I'm not able to do this demo because I'm only sharing the application window instead of a full screen. But you can, as long as you have R and R Studio installed, you can just double click the script that you get from Amanda, or you can right click and then select open with R, like how you normally open like a file. So once you have the script open, it should look like something. It should look like something like this I have on the screen. You will see 4 different panels here. So here, when I say script, this is the script. It's let's see, it has about 200 lines. See if we can go through all of it today. And this is an environment. This is a different window. So when we run the script to generate a data frame or create some object, we call them objects in R, it will show up here. Later you'll be able to see it. And this is a console. A console is where you can directly type your command, and it will also show you the outputs when you type a command. So you can just try to type something like, very classic example when people do this programming thing, say hello world, and then it will give you the output, hello world. Note, make sure you type this in parentheses. That just tells R you are inputting this a string of character hello world. If not, it will treat it as a command, and there's no command called hello world. So it will give you an error, but error is okay. It's work phone. You just get an error, but no big deal. Okay, so let's look at the script together. This is the Toolbox Tuesday session. You're welcome to email me with questions after this session. And today I hope to see if we can hit all of these milestones today. If not, that's okay. But we'll try to set up your work environment in R. We will, as we talk about, we'll try to use R to find and extract your census variables. And after we extract the variables, we'll try to get some quick descriptive statistics for your variables. And next, we'll try to visualize the changes over time. So we'll replicate the example I show you just now. And then we'll move on to another using the 1-year ACS to get annual data this time. And of course, we need throughout the script, we will do different exercises of cleaning and preparing your data that fit, so to make it fit your analysis. So to set up your R environment, you need to install the packages that you will be using. Think about like Microsoft. You need to install the Microsoft, and then you can use it. So this I make a little adjustment so it looks a little different from the pre-session materials I sent out, and hopefully this one works better. But before we go on to install these packages, there are a couple setups that we can check. For example, you need to go to Tools. If you can't follow, if I'm going too fast, I also leave the notes here. Okay, another thing to mention is that when you want to just leave a note in your script, just type a # and R will know this is just your own notes. It won't treat it as command. So back to the setting. We'll look at Tools, and then here at the end, Global Option, Packages, and make sure this Use Secure Download Method for HTTP is unchecked. So I think for a lot of default options, especially if this is the first time you're using it, it's usually checked, but make sure this one is unchecked, and then you can apply it or click OK, either way. And then is some other basics in running your command in R. You can either put your cursor here and hit run, or you can highlight a group of codes and hit run. And there's also keyboard shortcut. So you put your cursor here and you can do the keyboard shortcut, Control and Enter. So let's try these. We'll begin with this options line 21, and just put our cursor here and hit run. And there you go. This one should run. And as I mentioned, the output will show up here in your console. You don't see any error message, so that means the command is already ran. I put a note here. This is just something, a little trick to make package installation a little quicker, and hopefully it will work for most of you today. So next we are going to try to run a couple lines together. To keep it slow, let's do 4. Let's do 4 at a time. You can do all of them. So you can highlight all of them and then just hit run. I already have these packages installed, but I know it's going to take some time. Normally, I would install it with you as well, but today I think my laptop is a little wonky, so I'm afraid to risk it. I'm going to give you a minute here. You can try to just highlight these lines and then hit run, and then you will see a lot of text coming up in your console. That's just R. If you are installing these packages for the first time, that just are downloading the packages and installing it. So let's pause for a minute here and see if we can have these. Most of us can have these installed. And in the meantime, feel free to drop questions in the chat. Go to the chat. Yeah, I saw a question in the chat asking if the script can be opened using another software. You can open it in R itself. RStudio is a more user-friendly interface, in my opinion. And you can also open it in just text file. So in that case, you won't be running these files, running the script, but you can still see how that's written. Yeah. So someone mentioned that you can open it with Notepad. Um, and if you Oh, so for also sometimes if you get a warning message, sometimes warning is okay, but error means that it's not installed. Um, so we are at 132. I'm going to move forward. Hopefully most of you have these packages installed. And the next step will just be call these packages. Like you install your Microsoft and then you're going to open your Word, your Excel and your PowerPoint. So this one I'm actually going to run. So I highlight all of them and I'll just hit run and taking a little bit of time. Okay, all done. So when you see the little stop sign here go away, that means it's done. And I have some warning messages here and there. As long as it's not like a error, that means your script ran. And one thing here is that you can also go through the instructions here, not through R, but separately to get a Census API key. It's not like a requirement. Like today, I'm not calling my Census API key, but it's a recommended thing to do. So the one last thing to set up your work environment is to check your current working directory. And here the a function to check your working directory is called get wd, which should be just get working directory, short for that. And the structure of a function in R is it starts with the name of the function and then a parentheses. And in some cases, as you see later, you will type your arguments within your parentheses. But in this case, if you just want to get your working directory, you don't have to type any arguments in there. So you run this line, put your cursor here, run this line. You should see where you are at in terms of your working directory. So in my case, I have a Toolbox Tuesday folder that's created in my desktop. So later on, all the outputs that I created, it will be saved within this Toolbox Tuesday folder on my desktop. And if you don't want whatever your current working directory to be the working directory moving forward, like if you want to put it somewhere else, the way to do this is to use a function called set working directory or set wd. And this time you will actually put an argument, put the value of this argument within the parentheses. So here within the parentheses, you will just put the file path where you want all your files, all your Toolbox Tuesday files are. I don't want to make any changes, so I just pasted the same directory here. But if you want to make some change, as long as you keep this format correct, it should work. And then you run it, and then your working directory to be set will be set. And again, in my case, I have a Toolbox Tuesday folder on my desktop, and I want to create. This is like just like an exercise. I want to create a subfolder called output within this folder, and I use this function called dir.create. And inside, I just put the name of this subfolder. So this step is also optional, but I thought it'll be helpful to do a little more typing as a warm-up before the session. So you run this, you will get I get another warning message because I already have this. But again, warning message, sometimes it's okay, it will still run. So up to this point, you should have your working environment all set up in R, and we can move on to working with our census data. And before I move on, I do want to mention that you don't really have to, most of the time, you don't have to memorize all these functions names. I don't know if people actually can memorize everything. It just comes with experience, and it also comes from going to like sessions like the Toolbox Tuesday, and then a lot of the time you see how you look at some script examples, and then you can from there you can like see oh, these will be the functions that I'll be potentially using in the future. So it kind of just grows with the your learning experience. Okay, so now we officially start working with our census variable, and again, so the I think I get kicked out, right? I dropped off for a minute. Apology for that. Let's try to share that again, and we'll give it some time. Okay. Okay, I think I'm back online. Whew. All right. Our first objective, find your census variables. So the function we use to find our variables is called load variables. Sometimes if you're unsure what to put, how to use the function, one way to do it is to type a question mark and then the name of your function. So let's try that. Load variables. So here in the bottom right, it will show you, it will give you a description of this function and how to use it. You can see that load variables is for finding the right variables to be used with other functions in R. And here in the usage part, you can see what arguments you need to, what input arguments you need to put there. The first one is year, and then the second one is what data set. So these are looks like these are the data sets available to call through R, and this the cache is to whether to save it in temporarily save it. I usually just ignore it and use the default, and it will use the default option for me. So let's type all this together actually. So we'll load variables, and you can see that it automatically gives you the parentheses. And then let's see, we want to get our latest 5-year ACS data. So it will be 2023 is the latest data, and our data set, which needs to be in the parentheses. Put the parentheses. We want 5-year ACS, and that will be ACS 5 here. So we type ACS 5. So this is a complete command for R. It's telling R to load the variables for the 2023 5-year ACS. You can see I have a little smaller sign and then a little hyphen here that looks like a arrow pointing to the left. That's telling R to store the result in an object or item called census vars underscore 2023. You can call it something else, but that's just what I have for today's example. So let's take our time to do it together. Here we have the little left pointing arrow sign. We're going to store it in census vars underscore 2023. So this is the complete command. We're asking R to load the variables for 2023 5-year ACS, and we will store this entire in all the full results in census vars underscore 2023. And let's run this. This typically takes a little, well, 20 seconds here. And that's where I got my stats. There are 28,261 variables in 2023 5-year ACS. So you can see your object or data frame show up here. We can just click it and then it will open here. So this is a complete dictionary for 2023 5-year ACS, all the variables. It has the variable names, the label for it. There's a column called concept. It's like telling you what it is. And then it tells you the smallest geography available for this variable. Let's see. And here you can use it pretty much like in Excel. You can just search for it. So if you recall earlier, we look at a remote work variable B08006. We can just type it here. Okay. And it's like doing Control F in a Word document. And then all the variables with B08006 will appear here. So B08006 is actually just a table, and each individual variable has another like a 3-digit ID that follows the table name. So you can see that we have 001 total workers all the way down to 051. And that's like a subgroup. So here is like female workers that work from home. And so this table, under the concept column, you get the idea of this table, which provides sex of workers by means of transportation to work. So here you can see that for commute mode, in census terms, they use means of transportation. So this is helpful information because in other times, if you're not sure what your variable ID or what your variable name is, you might want to just type transportation here. So that's another way to search for it. Transportation. Now you get a lot more variables. So here it shows you how many entries you get here. That's a lot more than just B08006. You actually get, let's see. Well, you actually start with B08006, but if you scroll down, you can see there are variables from other tables that are included. So here you have B08113, and this is, you can also, okay, there you go. So you can see this table is for means of transportation to work by language spoken at home and ability to speak English. So that's a different way to slice your variable. So that's why knowing how to like search for your variables is important, because like just for like transportation, you get all these different variables, and a lot of them are still related to work from home. So now you can probably see that it's not real it's still kind of hard. If you don't know, you want to start with B0806, 006, it's still kind of hard to find your variables because this is like 2,000 variables, still a long list to go through. But I think one way you can shorten this list is to get a tabulation of this concept column because a lot of the variables, like for example, this sex of workers by means of transportation to work itself has like 51 variables, right? So if we can collapse it and just look at what concepts are available with that, what concepts that contain transportation within the data set, that's another way to find your variable. So I provide an example to do it here as well. Let's get to it. So here I just also call the 2013 data set. Actually, let's come back to it later. So this is the chunk of code that finds that tabulates what concepts within the data sets that contains the word transportation. It's more lines, slightly more complicated code block. So let's go through it. So census vars 2023 is what we already created. And this percentage sign, greater sign, and then percentage sign is called a pipe operator in R. It just chains operations step by step. So you mentally you can think of it as like, okay, we're going to call this object, and then next we're going to do something else. So it's just like telling R what's the next step needs to be we're going to do within this data set. So what there's a keyboard shortcut for it for Windows and for Mac, slightly different. But if you can't get used to the keyboard shortcut for now, you can also just type the percentage sign and greater and then percentage. So what we're going to do here, this is a function embedded within a function. So this grepl, it's a function that that tells R to look for the term transportation within the column concept. And it's not going to be case sensitive. So it doesn't matter capitalized or not capitalized. So find those rows where concept contains transportation and the filter function asks R to only show those rows. So this is one step. And then the next step, we tell R to do, we use the distinct function to tell R to only keep unique observation. So if you have like 50 sex of workers by means of transportation, only keep one. And next, we tell R to print the results. Here, like these arguments, I'm just telling R to make it have the width as in infinite, so it won't like trinket the results. That's just for better visual purpose. Again, you don't have to memorize this whole code chunk. It's meant to be something that you can just, if you have the script, you can just copy paste somewhere. The only place you might change is here if you load the variables and call it something else. So let's try to run it. So you see all the outputs are here. There are in total 55 concepts. So 55 tables that contains the word transportation in it. Some are more complicated, definitely longer. But to me, I think this is a slightly easier list to go through compared to the 2,000 entries or like a dictionary of all the variables within ACS. So here you can sort of get an idea what would be a helpful table to look into. So for example, I think the recent ACS, they have this variable tabulated for population in different races and ethnicity. So you can get get these variables for Asian or other races. And of course, there are other ways to slice the variable, like by occupation, by industry, by class of worker, etc. But for today's demonstration, we want to keep it simple, so we're just going to do sex of workers by means of transportation to work, which is the simplest one. And this does not give you the variable name. There are ways to do it in code, but I think that's slightly more complicated. So I just do another code to tell R so this is telling R to look for rows where the concept has this exact phrase, sex of workers by means of transportation to work. So this is different from concept containing the word transportation. This is telling R to look for rows with the exact value, and then we hit view, and that will give you the data set. So here you go. You get the same 51 variables that has this, and it gives you the exact variable name for each well, the name for each variable exactly. So to begin with, we will just look for one variable, this B080006_017. This gives you the total workers that work from home. So we won't be looking at other commute modes, and we're not looking at this variable by gender. So we'll just look at this 017 variable. So back here. And one more thing here is that using the same code, change the year to 2013, run it again, you will get, well, give it 20 seconds. You will get the similar dictionary, the full set of variables for 2013 1-year ACS. The reason to do it is that I want to double check the B080006 variable has the same name and same description. In prior data sets, this is important when we want to show trends over time. We need to make sure that we're extracting the same variable. So we can even double check with 017, and there you go. That's also workers that work from home in the 2013 ACS. So, and we can close this. All right, so hopefully spent quite some time talking about how to look for variables. Hopefully at least one method will speak to you, and it will be helpful to you. But the next thing we're going to do is to extract this variable in R. So earlier we have this B080006_017 workers who work from home. I'll just make a short note here. We'll be extracting this variable. And to give you another variable as an exercise, I also put median household income here, which is B19013_001. The function that we will use to extract ACS data is pretty straightforward. It's called getACS. Again, we can do our question mark and then get ACS to just get some pointers in terms of how to use this variable. You will see that it contains a lot of arguments. Some of these arguments, the inputs are optional, so you can ignore them, but there are some required ones which are here. So let's try to get, okay, let's type all this together to slow it down. We'll use the get ACS function. It automatically gives you the parentheses. So within the parentheses, you're going to type geography. So the first argument, geography, let's say we want tract level. So we're just gonna type tract in parentheses. And then the next one is variables. So for variables, we want this work from home variable from earlier. And for state, for this example, let's do California, but of course you can come back and do a different state like Colorado. And county, to replicate the example I showed you earlier, that will be orange. And year, the latest one is 2023. So after September, I forget the date, but when the 2024 data is released, you can change this to 2024 and you should be able to run it. And the next argument is survey. Survey will be ACS 5. So a reminder here is that we will be looking at track level variables, which are only available in the 5-year estimates. If you do ACS 1 here, it's not going to give you anything. And the last argument I put here, I put geometry as true. This is actually really handy, and you will see it in a minute. But it's something we tell R to contain, also extract the geometry for the data so we can do some mapping later. So you see all this is for get ACS. And then you see our little pipe operator here tells R the next thing to do is to mutate is a function for creating a new variable. Because this is from the 2023 5-year ACS, we want to create a new variable called period equals 2019 to 2023 as a little reminder that this is the time period for our variable. So again, we use the function mutate, and one last step is to actually do a rename here. Let me pause. Let me take a step back here. We can remove the pipe operator anytime. We'll just type it back. Let's see if I don't do this last step, what do we get? So here I'm gonna run, and you can see it's doing the magic here. So just like that, you extract your ACS variable using R. So here you can see you are looking at all census tracts within Orange County, and the variable that you extracted is, again, the work from home count, and the estimate is the value of these variables, and MOE means margin of errors. And then you have a geometry column that if you work with shapefile a lot, that actually looks like a spatial data file. And in fact, you can directly export this as shapefile. And the last column is something that you created. It's called period. And we specify, we put in 2019 to 2023 as our time period, just as a reminder. So here you can see we have this variable called estimate. It's not something extremely informative, and that's why I do one more step here to rename estimate into work from home. So later on, it will be slightly easier for me to remember what this is. So I put my pipe operator back and just now I hit run. And it will get override. And here I forget to mention, after all these, the results will be stored in this object called ACS data1, which shows up here. So this time, instead of seeing estimates here, it's work from home. So it will be just slightly easier later in terms of labeling and remembering what the variable is. Hopefully everything is going well. I haven't had a chance to check all the check the chats, but we'll make sure to go back to it to see if there are questions. So now we just extract the work from home variables from the latest ACS data. That's for 2023. And now we can easily tweak this whole chunk of code and get the data for different time periods. So here, if you look at this chunk, the difference is that the only difference is that instead of year equals 2023, it's year equals 2013. So I'm going to get data for 2009 to 20, the 5-year ACS 2009 to 2013. And and in that case, my new variable generated, it will be 09 to 13. And then instead of storing it in ACS data 1, I'll just store it in ACS data 2. We will run this. So there you go. You have ACS data 1 and ACS data 2 here. You can see, so here it gives you the number of observations. It looks a little different. That just means from the 2010 census to the 2020 census, the census tract boundary change. So you can't just do like a one-to-one match, but if you want to just like visualize the change across space and over time, like how I showed you earlier, that's still possible. So again, this ACS data 2, we created this. It's for a different time period, and it also have the same variable for work from home. So another tweak to this whole chunk of code is try with a different variable. So here I give you an example for income, where I left a note here. So 19,013,001, it's for median household income, and the year remains 2023. And so instead of rename it to work from home, I rename it to income this time. And I also store it in a new data frame just to keep each data frame smaller. Oops. You can't just highlight a chunk of the code to run. You have to either highlight the whole chunk or just put your cursor here. So run it again. There you go. So let's open it. And you can see it's for different variable this time. And now this column is income, which looks about right? Okay. So hopefully by now you have a slightly better idea about how to use the get ACS function. Again, you don't really have to memorize everything. A lot of the time is that we look at examples. It's the same as looking at the info tab here. We look at example, how it's done, and then we tweak it to extract the data that we want. One last thing here is that, as I mentioned, all these data extracted, it has a geometry column. So you can actually just directly export them as a shapefile. The function to do it is using st_write. So here you're telling R to export ACS data 1 as a shapefile call with this name. It's for 2023. So I put output here because I created a little output folder within my Toolbox Tuesday folder. You don't have to do it. You can just put the name here, and the outputs will be in your working directory, so not under any subfolder. And so this is telling R that you are going to overwrite if you already have the shapefile created there. I think I should be able to just run these. Oh well, give me a write error, maybe because I have it there. Oh no, because it's output. Here you go. Okay, yeah. I exported it because I run through it many times before I teach this. So it's deleting it and then it rewrite the layer. And you can do the same thing for for 2013. So again, if doing later on the mapping is too much in R, you can always just import the shapefile to GIS or somewhere that you're more comfortable with, or for more advanced mapping feature. Okay, so now objective 2 is to get some descriptive statistics of the data, and it's use a fairly simple function called SumUp. So here let's start with the income data we just got. We call the income data, and then next we put this line in just to tell R treat this as a data frame. This line is helpful because especially if it contains geometry in your data, so sometimes it's not treated as a data frame. So you tell R this is a data frame, and then you use the SumUp function to get descriptive statistics for income. There are different ways to get descriptive statistics, and this is by far my personal favorite because it just gives you everything from mean to standard deviations, and then from first percentile, fifth, 10, top quartile, all the way to 99 percentile and max. So yes, that's my go-to, but you will see other examples in terms of getting descriptive statistics. So right away, you can see that, let's see, P50, that's median. Median household income in Orange County is about 1100,000. And the max, this is capped, so the max is not really meaningful in this case, but you can see where the 99 percentile household income sits at. So that's an example. And let's try with our work from home stat. So here I do one more step is to combine ACS1 and ACS data 2. If you remember these two data sets, they are identical, except that one is for 2023 5-year and one is for 2013 5-year. And it's fairly simple to combine them. You just use this function called bind rows, and you store it. I just store it in a new data set called ACS combine. And when I have the ACS combined, the reason I want to do it is I want to look at their descriptives by time period. So this is very similar to this example. It first tell R that this is a data frame, and then instead of directly using SumUp, I first group the data by period. So this is basically telling R we will look at the descriptive statistics for each time period specifically. So we run this, and there you go. So, right away you can see that for the median number of remote workers at the track level increased quite substantially over this decade period, across these two time periods. Let's see, where's the mean? The means, the average are very different as well. It's almost, it's more than 3 times. And yeah, so basically the whole distribution of remote workers shift to the right. But a map will be helpful to show where these increases happen. And that's what we're going to do. I will pause after objective 3 because I do want to go through that. So we want to map workers that work from home, and the function we use is called map view. So the column we are mapping is work from home. Here there's an option to put in the layer names. So I just put workers work from home 2023 because I'm calling ACS data 1. I tell R to include the legend. And here, you don't always have to do this. Actually, I want to do this because later on you can see that I create several maps with the same cut off, so I can compare them. But let's see, if we don't use it, let's remove it for now. So if I just remove it, and also make sure you remove the little comma here. Comma is used to separate the different arguments within the parentheses. And let's see, if we just do that, we also store in map 1. So let's see. So believe it or not, map 1 is already created. It's just not showing, so we have to call it. There you go. So now you can see this map of, well, this is automatic, but it looks different from this. It just automatically generate the cutoff based on whatever default algorithm it's using. That's pretty close. So here you can zoom. I'm not sure. Are you all able to see the zoom version? Like a separate window with the map? Because I'm sharing the application, so I'm not sure if this is showing.
Echo, we can see the map in the bottom.
But you don't see a separate window. Okay.
No.
Because I'm only sharing the application, so if I click zoom, actually, if you're following, a separate window will be created where you can where it creates a better view, but I'm not able to show it here, so we'll have to stick to, well, I guess I can do this. Yeah, so it's interactive. It's already a very nicely looking map, and you can see the areas with the highest number of work from home remote workers is here in Irvine, and then also in this area. There's an option to change your base map. Usually this OpenStreetMap gives you a little more detail. And yeah, there you can see this is Gray Park in Irvine, Limestone Canyon. I don't know if I've been, but you can get pretty quickly you can get an idea of where the number of remote workers are highest within Orange County. So that's pretty neat. So let's come back here. So you can see the cutoff here is 2000. I think if we go back to the screen here, the highest is, so it automatically leave out the 2092 outlier or max. I think it's actually still, oh, it's gradient, so it's still included. But if you want to have a little more control over how this is shown, you can add the spec here. So here I'm telling R to for the legends start from 0, cap at 2200, and I want like 4 bins, which makes each bin 550. So that will capture everything. And let's do that again. And look at map 1 again. Yeah. So this time it gives you a different, like a slightly different view. So this is for mapping, and right away you can tweak this code to create maps for different time periods. And in this case, we will do it for ACS Data 2. And ACS Data 2 contains work from home estimates from 2009 to 2013. So I'll change the layer names here, and we'll use the same cutoff and see how it looks. I think it's run, and we'll run. display map 2. So you can see that using the same cutoff, really we don't see any areas that has green and yellow. So 10 years ago, the number of remote workers at the track level are pretty small. Most of them are in this lowest bin under 550. And if you use the sync function, you can quickly put these two maps side by side. And you can do a pretty clear comparison here. If you're able to have a zoom window, that gives you a better look, but I won't be able to do the demo here, so I have to drag it this way. So you can hover here and see the number. If you click it here, that's not easy to see with the small window. But yeah, you can see, let's move it. Here, work from home is over 2,000, and this is 400 work from home workers 10 years ago. And again, you can change your base map. And yeah, so pretty much these two maps, they are interactive and they are synced. And I think it's a very good way to visualize your change and then identify where changes occur most drastically. And it doesn't just work with the same variables. Here's a quick example. Remember, we also get data for income, and people often ask or say that remote workers might be correlated with income level. So we create another map for income. So this time we are mapping ACS data 3 and the income column. And let's run it and get the income map. Okay, there you go. So here, income. Again, it will be helpful to put this work from home distribution and income distribution side by side. And you can see that the relationship is not necessarily linear, right? You have these moderate income areas that has a very high number of remote workers, and you also have these high income areas where the number of remote workers are still pretty much unchanged from 10 years ago. Of course, we are not really looking at work from home rates here, so it might be a different story if you look at the ratio. But yeah, this is another way to look at the spatial correlation of two different variables. Okay, so we get through 60% of these objectives that's semi-anticipated. The last two examples will be the next objective will be to turn to 1 year ACS to extract the annual data. This is something I think is really helpful, but let's see. But I think I'll have to leave you to run this code at home. But basically, this is the code here. If we run through it together, it will create a time series for variables for the past for all the ACS available. So for example, here I'm extracting the data for all the way starting 2006, and I skipped 2020 because we don't really have data for it. And instead of extracting the one variable for work from home, I also get the 001 variable as well, and that's for total workers. So later it's easier for you to calculate the rate. So if I hit run here, you see it's doing some busy download here. Yeah, so you get basically, oh, I also, instead of doing Orange County, I switched this to Los Angeles County, but you can put a different county, you can put more county, you can put Orange, outside the region, Fresno, something else. So you can do this as well. How about we run this again? well, it takes a little bit longer because you're doing 3 counties, but basically, now for example, for each county, you get 2 variables: total workers, work from home workers, and you have the year created for each of them. So that kind of saves you the trouble from downloading each year from the census website or other data sources. And hopefully that again, you don't have to memorize the codes. Hopefully this is something you can just paste it in your R environment and cater and personalize it. Here are some extra codes for data manipulation or data wrangling. The main reason for doing this is that you can see the variable here are stacked together. It's not super easy to work with when you want to calculate something like a work from home rate, which is essentially this variable is divided by this variable. So ideally, you want a column for total workers, a column for work from home, so you can create a new column by through calculation. So I won't have time to kind of go into the logic of these codes, but this is essentially what these codes do. They pivot this data set to a wider format. I call it annual data underscore annual 2. And now you have these 2 variables pivoted there. And the rest you can do is to rename them so it's easier to understand. So here I rename workers, rename 001 to workers, 017 to work from home, and then I calculate a new variable, which is the share of work from home workers or work from home rate, and then I run it, and there you go. So, and it's automatically done for each county as well. So this chunk of code is also, you can put in lots of, you can like tweak it and make it fit your analysis. And here, for example, you can already make a time series trend chart for Los Angeles County's work from home rate. And of course, you can also export this data to Excel, where you might have a little more options and controls in terms of creating these charts. The last one, I just put it here as an example. I'm not an expert chart creator in R, but this is something that can create like a fairly quick chart for the counties that you extracted. Apology for flying through the last 2 objectives. Hopefully these will be posted, and hopefully you will find it useful at some point in your work. Thank you. I'll pass it back to Amanda.
Thank you so much, Echo. And Jennifer, if you can bring up the slides again, please. All right, we just wanted, oh, the next slide, please. Oh, sorry, I have slide control. We wanted to let everyone know about our demographic workshop happening on October 1st at 9 a.m. with both in-person and online options. The theme of this year's workshop is revisiting the intergenerational contract, and we'll gather local leaders, elected officials, and regional experts to network and discuss key demographic signals specific to Southern California and its local communities. Expert insights will reveal quality demographic data crucial to achieving long-term regional and local planning goals, such as those defined by the Connect SoCal 2024 RTP SCS. And you can register. Virtual online registration is free, and you can register at the following link. And the last thing before we let you all go for this afternoon, we have a super quick survey. If you could take that, let us know how we're doing, how we can improve, and what types of topics you want to see in the future. And then finally, this session is eligible for APA AICP CM credits, which you can claim at the following link. And with the 3 minutes we have left, I believe we got to most people's questions as we were going through it. But Echo, there appears to be one from Arash that asks, so how does Get ACS work if we want to go beyond census tracts and say look for census block groups or census block data? Should we include census tract name inside the function parameter as well?
Yeah, I just pasted the code in the chat. So pretty much instead of
Oh,
using geography equals tract, you can just use geography use equals block group, and in that case, you will have block group downloaded for block group level data downloaded instead of tract level.
awesome. I want to thank Echo again for all the work that you put into this demonstration. I would also like to thank our AV specialist, Jennifer, for helping this run smoothly despite our technical issues. And thank you all so much for attending today and have a great rest of your day. Thank you so much.